Leetcode problem 2147, number of ways to divide a long corridor. So let me try to explain the problem. So what is this meaning? A long library corridor. Oh, this is so difficult to read. I don't want to read it. So there is a line of seats and decorative plants. So this is the seats and this is the decorative plants. And we are giving a zero-indexed string corridor of less n consisting of letters S and P. So S means the seat and P means the plant. So one loop divider has already been installed. So this means at the left side there's a divider. And then we just need to find all other possible dividers to make it. We're gonna split it as two seats. So for example, at the left side there are two seats, and at the right side there are two seats. So this is one possible way, and this is another possible way. At the left side there are two seats, and the right side two seats, and this is the third way. Yeah, but if we put it here, that is not possible because there are three seats at the left side, one seat at the right side. Definitely, it's not possible. So in total, there are gonna be three different cases. So this is gonna be the first example. Let me just check if we can find more examples. Yeah, so for other examples, it's not so difficult to, it's not a very good example to explain, but let's just use this example. So this means we can find three different cases. Yeah, but what if after those two seats, there's another maybe seat, and this is a plant, and this is another seat. Yeah, those are two other seats. So this means after those two, definitely we can split it here, and that is okay. Yeah, but that is only one possible way. But let me try a better example. So a better example would be, so after this one, there's gonna be a plant, and there's gonna be a plant, and this one gonna be a seat, and this one gonna be a seat. Yeah. So this is a seat. After this one, this means we can split it here, or split it here, or split it here. It means three places. So this means the final result gonna be 3 times 3. And we should understand the mathematical formula. How can we calculate it? Because this is basically, in mathematics, it is basically combinatorics, and both of them are independent. So for here we find 3 different cases, and for here we find another 3 different cases. So in total it's going to be 9. How can we solve it easily? So we need to record what is going to be the previous seat. So for example, this seat we find, this seat is going to be the third seat. Yeah. And this seat is going to be the second seat. So the distance between them is going to be 3, and the distance is exactly what we need to calculate. This is, because for here, this is the previous seat, it's going to be the second, and this is going to be the third. So this means from here, 1, 2, 3, we can have 3 splittings. Definitely this is our answer. Now, the hard problem becomes an easy problem. Let's just try to solve it. So let me prepare the final result and pray. This means the previous position of the seat, and I also need to prepare a counter. So let me define it as seat count seat. So from the beginning, the result is going to be 1, and the previous position is going to be 0, and the count seat is going to be 0. Yeah, because this is basically multiplication problem, so we're going to prepare the result to be 1. So finally, we're going to return the result. Now, for IC in enumerate the corridor, we need to check if we can find a seat. So if we find a seat, what are we going to do? So the count seat is going to plus equal to 1. So if the count seat more than and equal to 3, this means it's going to be the 3rd, 5th, and 7th. So definitely we can calculate it. Yeah. And the count seat is going to be odd, modulo 2. So this means we can directly calculate it. So the result gonna be result times I minus the pre modular the mod, and after that we're gonna update the pre. The previous position gonna be the pre. We can update the pre from here. So the previous position gonna be I. Yeah, because this is a if. If it is a set, we're gonna record the previous position. Definitely we need it. Yeah. So from here, if that is valid, it's gonna be the 5th, 7th. It must be the odd positions, so we can update the final result. Yeah, I think that's basically about it. But let me just run it. What is wrong? So yeah, I didn't prepare the mod. Let me just prepare mod because I didn't recognize it's going to be a mod. Let me just define this mod. It is +7. Let me just run it. Yeah, now as you can see it works, but it didn't work for the third case because we didn't check that. Yeah, because it can be 0, so the set is not modular of 2. It must be modular 2 equal to 0 because there's only one set, so this means it is not valid. So if we were to return the final result, so we need to check the count set. It's going to be more than 0. Yeah, if count set more than 0, it's going to be a number, and the count set going to be even modular 2 equal to 0. Otherwise, it is not valid. We're going to return a 0. So this is just the final check. So this means if the count set is 0 or 1, definitely it didn't work, or 3, it didn't work. Yeah. Now let me just submit it to check. As you can see, it's pretty fast and it passed for all testing cases. And the time complexity is just ON. We just need to loop through the corridors array and to find which one gonna be okay. As we can see, we don't need to. Yeah, we just need to check this position, the third position, for the set. So this is the previous position. So the index is going to be 1. So the third position, the index is going to be 4. 4 minus 1 is going to be 3. And this is our answer. And if we find more, we're going to use the multiplication to solve it. I think that's basically about it. Thanks for watching. See you next time.